So we're looking at volumes of prisms and cylinders. We're going to start with a rectangular prism, or it could be a cube if all the sides were the same. In a rectangular prism, we have three dimensions. We have the length, the width, and the height. We can think of this bottom side here as the base in a rectangular prism, but really since they're all rectangles, any of them could be bases. So if we look at our first one and finding the volume, you're really going to multiply your three dimensions, but it's good if we get into the good habit of just thinking as a base. In this case, I'm thinking of 9 and 17 as a base, so I multiply those two first values, 9 times 17, and then the 24 would be the height. Since it's multiplication, we just go in and go 9 times 17, which gives me 153, and then multiply that by 24, and you get 3,672, and that's centimeters cubed. Whenever we go volume, it'd be cubic centimeters. We have three dimensions. For number 2, we're going to think of this one as the base, 10 by 14. So we're going to go 10 times 14 times 19.5. 19.5 would be 4.5. So 10 times 14 is 140. We multiply 140 then by 4.5, and we get 630 inches cubed. Now, that's if we have a rectangular prism. Let's look down if we have a triangular prism. So now, in this triangle, this is our base of the triangle. So we have this bottom triangle and this top triangle. We know they're the bases because they're the non-rectangles of it. So if I draw that triangle off to the side, the base, and this is a good habit to get used to, we can label the parts we have of it. Now, 12 is the bottom side of the triangle, 7.3 would be like the height of the triangle, 9 and 10 are two other sides, and this 5 is the height of the whole prism. It's not actually in the triangle. So when we find the volume of this, we're going to do the base area times the height, which is 5. Now the base area, as complicated as it sounds, just means what's the area of the triangle. So our area of our triangle here is 1/2 12 times 7.3. So that part, we get half of 12 is 6, so 6 times 7.3, bring down the 5. 6 times 7.3 is 43.8, times 5 gets us 219 feet cubed. Now, what if we change the shape again? What if we then had a trapezoid, which is what we get to number 6? In our trapezoid, if we draw it off to the side, we have 36 as the top side. It's right here. 14 is the bottom. The height here is 17.9. One of the legs is 21. And this 25 isn't on the actual trapezoid. It's a part of the height. So that's going to be that 25 we throw at the end for the height of the prism. So we still got to find base area. The area for a trapezoid is 1/2 base 1 plus base 2 times the height of this shape. So we're going to go 1/2 36 plus 14 times 17.9. This is what we're going to calculate to put into here. So 36 and 14 is 50. So we got 1/2 of 50 times 17.9. That's going to be 25 times 17.9 gives us 447.5. So if the question was what is the area of the trapezoid, we would say 447.5, but now we multiply it times the height of the whole prism, and we get a volume that is 11,187.5 meters cubed. So you can go back and try these as we go, but what if we now jumped to number 9? Number 9 is now a cylinder. In a cylinder, we've changed it from being base area times height to pi r squared times height. And the reason is, in a circle, the area of that circle is pi r squared. So what's nice about this is we don't necessarily have to remember the area formula for the base, because we just have the area of a circle always being constant. So we really need to know two things, radius and height. So pi r squared times height, we're going to go pi times 18 squared times 15. 18 squared is 324. That's going to be multiplied by 15 pi. So multiply 324 by 15 and we get 4,860 pi inches cubed. Now, number 10, we've changed it a little bit. 11 is the diameter. We need the radius, so that's 5.5. So we're going to go, volume is pi r squared times height. So that's pi times 5.5 squared times 21. 5.5 squared is 30.25. That's going to be multiplied by 21, which becomes 635.25 pi. That'll be meters cubed. So anytime we have a cylinder, look for the radius, look for the height, plug them in to solve. That diameter part is the part we really got to be careful with. So then we look at the different ways we can solve this. I have a triangular prism and I have a cylinder cut into the middle of it. I need to find the volume of the prism and subtract the volume of the cylinder. Now what we're looking at here with this prism is it's a 5, 5, and 7.1 on the dimensions of it. What's nice about this is it's a right triangle because I have the 5 and 5. We also notice this little right angle right there, which is going to help us solve it. So this actually would be a 45, 45, 90 because you get 5, 5, and 5 root 2, which is 7.1. Now, 14 is also the height of that, so we're going to go through and try the volume of the prism. We're going to subtract the volume of the cylinder. Now the cylinder has a 2 centimeter diameter and a height of 14 centimeters. So we're going to go volume of the prism minus volume of the cylinder. Our prism, the base area is 1/2 5 times 5, because it's a triangle, 1/2 5 times 5, times a height of 14. The cylinder has a radius of 1, because the diameter of 2, so that's going to be pi times 1 squared times 14. Now, inside the parentheses here, I get 25 over 2 times 14, which becomes 25 times 7, if I just took half of 14. 25 times 7 gives us 175. I'm going to subtract from that. 1 squared is 1 times 14, which is 14 pi. To get an answer here. This would be the answer in terms of pi. We could accept that, or you can multiply out, get your decimal, and get a decimal answer. So I want you to go through, try the other ones.